Hello everyone. In the last videos we have seen problems on the period 2 pi and the arbitrary period 2l. Now let us see what is half range Fourier series. So if a function is defined over half the range, say 0 to L or 0 to pi, instead of full range, it may be expanded in a series of sine terms or cosine terms only. That is known as half range Fourier series. For example, we have seen 2 pi, interval 2 pi and the arbitrary period 2l. So here half of this interval is nothing but pi and half of this interval is nothing but L. So we will discuss half range Fourier series in the interval 0 to pi and half range Fourier series in the interval 0 to L. And in half range Fourier series we have two types. One is sine half range Fourier series and the second one is cosine half range Fourier series. And sine half range Fourier series is defined in two intervals. One is between 0 to pi and the second one is between 0 to L. In the same manner, cosine half range Fourier series is also defined in two intervals. The first one is interval 0 to pi and the second interval is between 0 to L. First let us define what is the sine half range Fourier series and let us see the formulas related to sine half range Fourier series. So sine half range Fourier series. A Fourier series which contains only sine term is called as sine half range Fourier series. So this is the definition of sine half range Fourier series. F of x is equal to summation n equals to 1 to infinity bn sine n pi x by L, where bn is equals to 2 by L integral between 0 to L f of x sine n pi x by L into dx. This is the sine half range Fourier series in the interval 0 to L. Similarly, f of x equals summation n equals to 1 to infinity bn sine nx, where bn is 2 by pi integral between 0 to pi f of x sine nx dx. This is sine half range Fourier series expansion in the interval 0 to pi. Now let us define what is this cosine half range Fourier series. The Fourier series which contains constant term and cosine terms are called cosine half range Fourier series. Let us see the definition of cosine half range Fourier series. F of x equals a naught by 2 plus summation n equals to 1 to infinity a n cos n pi x by L, where a naught is 2 by L integral between 0 to L f of x into dx, and a n is 2 by L integral between 0 to L f of x cos n pi x by L into dx. This is cosine half range Fourier series in the interval 0 to L. Similarly, f of x equals a naught by 2 plus summation n equals to 1 to infinity a n cos nx, where a naught is 2 by pi integral between 0 to pi f of x dx, and a n is 2 by pi integral between 0 to pi f of x cos nx dx. This is the cosine half range Fourier series in the interval 0 to pi. Suppose if the function is odd, we will come across with sine half range Fourier series expansion, and if the function is even, we will come across with cosine half range Fourier series expansion. Here we will not find out the nature of the given function. In the problem itself they will specify that to find out whether cosine half range Fourier series or sine half range Fourier series. Depending upon the question, we should apply the corresponding formulas. Now let us see the problems. The first problem is like this. obtain sine half range Fourier series for the function f of x equals x square in the interval 0 to pi. So here in the problem itself they have given obtain sine half range Fourier series. So directly we can find out sine half range Fourier series, that is only Bn term will calculate it, and the given interval is between 0 to pi. So we should write down the corresponding sine half range Fourier series in the interval 0 to pi, that is f of x equals summation n equals to 1 to infinity Bn sine nx. In this problem, no need to verify the nature. Directly it is given as sine half range Fourier series. Just we need to write down the corresponding Fourier series expansion and will calculate Bn. Bn is given by 2 by pi integral between 0 to pi f of x sine nx dx. So 2 by pi integral between 0 to pi, substitute f of x as x square into sine nx dx. Now we have product of two terms. Let us apply Bernoulli's rule of integration and will integrate it. So Bn is, here the first function is x square because it is an algebraic function, and sine nx is the second function. So 2 by pi will keep it as it is. Bernoulli's rule is first term into integration of sine nx is minus cos nx divided by n, minus integration of this cos nx is minus sine nx divided by n square, into differentiation of x square is 2x, then plus again integration of sine term will be minus cos nx divided by n cube into differentiation of 2x is 2. This is between the limit 0 to pi. Now let us substitute the limits. If we substitute the limit for sine term, let us substitute it and will verify whether it is 0 or not. When I substitute the upper limit sine n pi value is 0 and lower limit sine 0 is 0. So this term will be 0. Bn equals 2 by pi into upper limit for this term is minus pi square into cos n pi divided by n, minus lower limit is 0 into cos 0, it is 0 only. Then we will apply the limits for this term. Minus 2 by n cube is a constant, upper limit is cos n pi, minus lower limit is cos 0. Bn is 2 by pi minus pi square by n into, we know that cos n pi value is minus 1 to the power n, minus 2 by n cube into, again cos n pi value is minus 1 power n minus cos 0 is 1. Let us multiply this 2 by pi to these two terms. So 2 by pi into minus pi square by n into minus 1 to the power n will be minus 2, here one of the pi term gets cancelled, 2 pi by n into minus 1 to the power n, then plus into minus will be minus 2 2s are 4 by pi n cube into minus 1 to the power n minus 1. This is the value of Bn. After getting Bn, we should substitute back in equation 1. So f of x equals summation n equals to 1 to infinity, Bn is minus 2 pi by n into minus 1 to the power n minus 4 by pi n cube into minus 1 to the power n minus 1 into sine n x. This is the required sine half range Fourier series for the given function f of x equals to x square in the interval 0 to pi. This is how we should calculate sine half range Fourier series. Let us take up the next problem. Obtain sine half range Fourier series for the function f of x equals 1 by 4 minus x in the interval 0 to half and x minus 3 by 4 in the interval half to 1. Here the function is splitted into two functions, and observe the interval is between 0 to 1. So that means it should be compared with 0 to L. It cannot be compared with 0 to pi. it should be compared with 0 to L because it is an arbitrary function. So, the corresponding sine half range Fourier series expansion is f of x equals summation n equals to 1 to infinity bn sine n pi x by L, where bn is 2 by L integral between 0 to L f of x sine n pi x by L into dx. Now, let us substitute for L 2 times integral between 0 to 1 because L is 1 for this problem. F of x into sine n pi x by L into dx. But here f of x is splitted into 0 to half and half to 1. So, this integral has to be splitted as 2 times integral between 0 to half and half to 1. So, between 0 to half our function f of x is 1 by 4 minus x into sine n pi x by L value is 1. Between the limits half to 1, my function f of x is x minus 3 by 4 into sine n pi x into dx. Now, we have product of two terms in both the integrals. So, we will apply Bernoulli's rule of integration and will substitute the corresponding limits. So, let us integrate it 2 into here first function is this, second function is this, and this is the first function, this is the second function. So, 1 by 4 minus x into integration of sine n pi x is minus cos n pi x divided by n pi minus again integration of this integrated function is minus sine n pi x divided by n square pi square into differentiation of 1 by 4 minus x is minus 1. This is between the limit 0 to half plus. Let us integrate this by applying Bernoulli's rule of integration. First function is x minus 3 by 4 into integration of sine is minus cos n pi x divided by n pi minus integration of this integrated function is sine n pi x divided by n square pi square into differentiation of x is 1. This is between the limit half to 1. Now, let us substitute the limits. 2 into 1 by 4 minus 1 by 2 is the upper limit. 1 by 4 minus 1 by 2 into minus cos n pi by 2 divided by n pi. This is the upper limit for the first term. Similarly, for the first term lower limit is 1 by 4 minus 0 is 1 by 4 into minus cos 0 divided by n pi. This is the lower limit for the first term. Then here minus into minus into minus is minus, upper limit is sine n pi by 2 divided by n square pi square, and lower limit is sine 0 will be 0. Then we will go to the next term. This term we have minus sign, upper limit is 1 minus 3 by 4 into cos n pi divided by n pi. This is the upper limit value. So, minus of minus will be plus half minus 3 by 4 into cos n pi by 2 divided by n pi. This is the lower limit value. Then for the last term, minus into minus will be plus, upper limit is sine n pi divided by n square pi square, which is 0, minus lower limit is sine n pi by 2 divided by n square pi square. Now, let us simplify the terms, which is equal to 2 into 1 by 4 minus 1 by 2 is minus 1 by 4. Minus 1 by 4 into minus cos n pi by 2 by n pi is plus cos n pi by 2 divided by 4n pi. This is plus term. Then here minus into minus again plus, we know that cos 0 is 1. So, plus 1 by 4n pi. This term should be retained as it is, minus sine n pi by 2 divided by n square pi square, minus here again 1 minus 3 by 4 is 1 by 4, and cos n pi is minus 1 to the power n divided by 4n pi. Then half minus 3 by 4, half minus 3 by 4 is minus 1 by 4 n pi into cos n pi by 2, this term. Then minus last term is sin n pi by 2 divided by n square pi square. Here plus 1 by 4 n pi cos n pi by 2 and minus term gets cancelled. Let us combine the remaining terms and simplify. 2 into 1 by 4 n pi minus sin n pi by 2 minus sin n pi by 2 divided by n square pi square is there. So, it is minus 2 times sin n pi by 2 divided by n square pi square, and this term is minus 1 par n divided by 4 n pi. This is the value of Bn, or we can multiply this 2 to this term. It will be 1 by 2 n pi minus 2 2s are 4 into sin n pi by 2 divided by n square pi square minus 1 by 2 n pi into minus 1 to the power n. So, after obtaining Bn, we should substitute back in equation 1. So, that gives f of x equals summation n equals to 1 to infinity. Bn is 1 by 2 n pi minus 4 into sin n pi by 2 divided by n square pi square minus 1 by 2 n pi into minus 1 to the power n. This is the required sine half range Fourier series. We will continue the problems in the next video.